And next up, we have Reuven, who is a professional teacher and speaker in Python community. And he will bring us what's happening when you import the module. And if you have any question during the session, you can ask the question on our Slido. And you can find a Slido link on our schedule page. So let's welcome Reuven.
Yeah. It worked already, a success. All right, everyone. Hey there, and welcome to my talk. This is what happens when you import a module. And just to remind you, this is what I do. I teach Python basically every day. I'm in, or virtually or really, a different city, a different country, a different company, helping people with their Python. I also offer lessons online. You've probably seen my booth. If you have not yet, you should come by my booth. Please take a shirt. Please take chocolate. Sign up to get free copies of my books. And I do newsletters as well. All right. Let's start with a basic principle that I always love to talk about, which is DRY. Don't repeat yourself. This is a really important idea in programming. And we often want to, as we call it, dry up our code. What does that mean? Well, it means that if I have the same code several lines in a row, then I should replace that with a loop. I don't want to repeat myself. If I have the same code in several places in a program, then I should use a function and then invoke that function multiple times. Well, what if I have repeated code in several different programs? Well, then I can put it in a library. And a library is a term that we use in many different programming languages. This is not a uniquely Python thing. But in Python, we call our libraries modules. And they are usually, not always, but usually files, individual files that contain code. Now, one of the things that makes a Python module different from just a library is that it also provides us with a namespace. What does a namespace mean? It means that if I'm working on a project and I'm working with someone else, I'm collaborating with someone else, and I use a variable named X, and they use a variable named X, we don't want them to collide. And so we can use namespaces to set things off. And in Python, we do that with modules. It's sort of like having a family name to distinguish between people of the same personal name. So we use modules all the time in Python. It's like not even something we think about a lot. And while I was teaching, at a certain point I said, I think I understand what happens when we import a module, but do I really? And it turns out it gets very complicated very quickly. Get ready. So basically, let's import a module. Import random. And we do this, again, all the time. We don't even think much about it because we say, okay, I want to use what's in the random module. But what is this actually doing? So really, this import statement, and notice it is not a function. It is a statement. It's not, there's no parentheses here. Moreover, that random there, we're not passing it a string. We're going to talk about that more in a moment. But really, you should think about import doing two different things. The first thing it does is it creates a new module object. And the second thing it does is it assigns that module object to a variable. It is very similar in many ways to def when we define a function. What happens when I use def? I create a function object and I assign it to a variable. So that's happening here too. And indeed, after we have imported, as we'll see, we have now assigned to a variable. So a few things to notice. As I mentioned, import is a statement. It is not a function. Don't use parentheses. It won't work. The second thing, which is surprising to many people who come from other programming languages, is that we give the name of the variable we want to create. We're not giving it a string. We're not giving it a file name. So in Python, you cannot say, hey, go load this file. It does not work that way. Instead, you say, this is the module I want to work with, and you let Python do its magic. And we're going to talk about that in a moment. So indeed, if I now say import random, and then I ask Python, hey, what's the type of random? It will say module. This is an object type. And truth be told, it's a very simple kind of object. It's basically just the namespace using attributes. So if you look, and we will soon look, at a module object, you will see it just has a bunch of attributes, the names of the variables that were in the module we loaded. And modules don't have any methods. They are just there for storage. You can think of it as sort of like a warehouse, sort of like a storage facility for our values. Yeah, but what if I don't like the name? What if I want to import a module but use a different name for it? So I use as. So when I say, I'm going to walk around a little bit, right? So when I say here, import random as R, what am I doing? I'm still telling Python, go find the random module, we'll see how in a moment, and create a module object with it, and then assign it to random. But wait, don't assign it to random. Assign it instead to R. So everything we talked about before is true, but the variable name that is created is different. Now, why would I want to do this? Maybe it's a convention thing, right? So if I'm using NumPy or Pandas, everyone says import NumPy as NP. Everyone says import Pandas as PD. By the way, I did not when I started using them. I was like, I type fast. I don't need that. And then I discovered why everyone does it. Because everyone wants to copy and paste from other people. And then, if you don't say import pandas as PD, you're out of luck, right? So also, you might have conflicts with your variable names. And so using import as is very helpful. What if module A imports B and module B imports A? Well, this could be a problem, right? We don't want an infinite loop. Now, there are certain languages out there, languages whose names rhyme with C. And in those languages, we have to worry about this. That will get ourselves into an infinite loop where we have to do like setdef and ifndef and all sorts of stuff. But actually, this does not happen because Python only imports a module once per session. If I say import A, it does go and import it, but only the first time. After that, it will cache it. And we're going to see that in just a moment. But it will always define the variable. So import A will always define A, overwriting whatever we had there before. But this does raise the question, how does Python know if the module has been imported already? And the answer is sys.modules. So the sys module is basically the Python runtime. It has all sorts of information in it, and it is automatically loaded, although the variable name is not defined. So you have to say import sys. And this is a dictionary. It's a dictionary whose keys are strings, the names of the modules, and whose values are the module objects. When you learn about dictionaries in Python, you learn that the keys are restricted. They have to be unique, they have to be hashable, but the values can be anything. And here we see the values can be module objects. And so when we import, Python checks, is that module already there? If not, then it goes, finds the module, imports it, creates the module object, and assigns it to sys modules. But if it is already there, then it just assigns the global variable. So how big is it? Right, sys.modules, if it's the cache of all of our modules that have been imported, how big is it? So I was curious about this. So I opened up the Python interactive shell, just like Python or Python 3 on the command line. I said import sys and show me the len of sys.modules. And the answer is 75. Well, that's pretty good, right? But wait, how often do I use the Python interactive shell? I am a super Python user. I use IPython, right? And so if I say import sys and len sys.modules, how many are there? And it turns out a lot more. But wait a second, I use Jupyter a lot. What if I do it there? And the answer is 1020. Now, it's worth it, right? Like Jupyter gives us a lot, IPython gives us a lot, but these are the modules that are loaded as support for all these backend systems. So what I want to show you now is simplified versions of what import is doing. I wrote these in Python, right? But this is not really the implementation, and it's more complicated than this. Don't really run this code. Instead, if you want to experiment with Python's import system, you should use importlib. And that is a full implementation of the import system in Python that you can use and play with. And it's meant to be read and imported and studied and all that stuff. And I will refer to this more. So what happens when we import? I wrote a function here called myimport. So def myimport of mod. And here, I'm going to have to say, like, what is the module? Again, it's pseudocode here. So if the mod name, I should have called it mod name, right? Oops. If the module is not in sys.modules, so Right, fine. Hold on just a second. Let's just fix this. This is driving me crazy. There we go. As I was saying, if mod, not in sys.module. So if we have not seen this module before, then we're going to say get module of mod for and assign that to sys.modules of mod. Right? And then, all right, so then we do this. This is kind of wild. This is actually, globals is a dictionary referring to all the global variables in Python. So if you use globals, if you invoke globals, you will get a dictionary back and you can actually assign to it. So what am I doing here? I'm loading the module if I need to, and then I'm assigning it to a variable of that name. Yeah, wait a second. What is this get module thing doing? Like, that's sort of papering over all of the real implementation, right? Well, before we get to that, what about import as? Well, we can just do it like this. Def my import mod, and then we have an alias equals none, right? So that's an optional argument. So now I once again say if mod not in sys.module. So if we've not seen this before, then we're going to load it and we're going to assign it to sys.modules of mod. And then which global variable am I going to use? Well, if alias is none, then alias is mod. Otherwise, we'll just use the alias and globals of alias, sys.module mod, fantastic. So now that we've seen what happens when we import and what happens when we import as, we can go back to what I said before. What happens if my program says import A, module A says import B, and then module B says import A? How does this make sure that we're not going to get an infinite loop? And basically, okay, our program says import A, and A is not in sys.modules, so it's loaded. And then we assign to the global variable A. And then module A loads B. So B is not in sys.module, so B is loaded. And the global variable B is assigned to sys.modules B. So far, so good. And then B imports A, and A is already in sys.modules. So we don't need to load it, but we do assign the variable. And this is what happens. This is how we avoid infinite loops. But this is why also we don't have to worry about the variables being defined. They will be defined. Yeah, but what about global variables? Right, because in many languages, a global variable means it's available throughout the entire language, and that's not what it means in Python. In Python, when we have a global, it really means it's global in that file, right? So if I have a file of Python and I assign to X outside of a function, that's a global X, but it's only X inside of that file, or if you prefer, in a particular namespace. So module A can have a global X that's totally different from module B's global X, and that's a good thing. That shows the power of namespaces. That means that we're not going to have these sorts of sort of cross-cutting of things. Which namespace are we in at a given time? We can always find out with dunder name. Dunder name is a variable, and it returns the name of the current namespace. And the first namespace, when we load up Python, is dunder main. By the way, dunder name is a variable. Dunder main is a string. How could people possibly ever get that confused? I don't know. Also, this is why when we have a file at the bottom, if we say if dunder name equal dunder main, that means we are in the first file that Python is loading. No one else has imported us, and we can then run knowing that it's interactive. Right? It's not like a C kind of thing where we must have a main function. This is just a convenient thing to be able to distinguish between when our file is being loaded and when our file is being run. So let's rephrase things a little bit. So our program says import A. A is not in sys.modules, so it is loaded. Global A is assigned to sys.modules A. Fantastic. And then module A imports B. B is non-sys.module, so B is loaded. And A.B, A.B is assigned to sys.modules B. Right? Notice that there, right? So already we've got like a namespacing thing going on. And module B imports A. A is in sys.modules, but B.A. So now we have a global A, we have A.B, and we have B.A. Now everyone has access to A and B from within their files and from within their namespaces. Yeah, but you know it doesn't stop there. You've probably seen this. From random, import randint. Now, I cannot tell you how many people think that this saves memory. because I'm only going to import one little part of a module? The answer is no, it does not save memory at all, because it loads the entire module into memory. The only thing that this does is change which global variable or variables are defined. In other words, when we use from import, it is still doing the first part of what I talked about. It's loading the module, if necessary, into sys.modules. It's the second part, the assigning of a variable, that is different. So we can do it like this. From random import randint. Once again, it checks if random is in sys.modules. If not, it loads it, and then it defines randint. By the way, random is not defined in this case, right? People are also surprised by this. The random module is loaded, but the random variable is not defined. These are two different things that we have to separate. Well, can I write pseudocode for this too? Of course I can. So I'm going to say here def my from import. So this is another function, and we're going to take a module, and we're going to take splat names. We're going to take any number of positional arguments indicating what names I want to import from this module. And the first part remains the same. If mod not in sys.modules, sys.modules mod equals get. This is what we saw before. But then the second part is new and different. I'm going to say for one name and names, globals of one name, meaning I'm going to assign into the global variable what? I'm going to do this horrific thing. I'm going to say, go into sys.modules of mod, go into our module object, grab the attribute for that name, get the value, and assign it. And getAttr is a built-in function that retrieves attributes. We name the object, we name the attribute, we get it back, and we assign it. And of course, we can do it all together. We can say from random import randint as ri. How the heck will we do that? Well, oh, I needed to use here. Hold on, this needs to be. Wow, lots of corrections in real time. Fun stuff. All right. Now I'm not going to use a splat names. I'm going to use double splat names, because now it's going to be a dictionary. Name, value, name, value, name, value. So I'm going to load my module again, but then I'm going to go through this dictionary, one name value pair at a time, take the name, take the value, and assign it accordingly. In other words, we will get all of the names that we wanted assigned, and we're only going to load the module a second time if needed. So this means, by the way, that if you have a very large software project with, call it 10 files, 20 files, and every single file starts with import numpy as np and import pandas as pd, those modules are being loaded once, and the variables are being defined many times, each in its own namespace. But that's okay, because assigning variables and assigning attributes is very fast. Yeah, but I've been papering over this thing, this get module. What does get module do? Right? I sort of was like, yeah, you know, we get the module. So this is where things get a little complex, right? So I call it get module, and it's going to take a module name as input. But then it needs to do two things. It needs to find the file associated with that module, and then it needs to load the file in and create a module object. And that module object then is what we're going to store in sys.modules. So we're going to have to find it, and we're going to have to load it. It turns out, by the way, there really is a get module function. It's just called importlib.import module, but it really does exist. There's also, by the way, something called dunder import. Don't use it. Please don't use it. Not meant for us. So now what? Well, if I say here r equals importlib import module underscore of random, that's going to go off, find the random module, thanks to the string, return a module object, and the type of R is now module. So that's great, but what does it really do? Let's find out. Well, it works, that's for sure. So let's talk about finding, and then let's talk about loading. How does Python find modules? Right, so I say import random. Where is it looking? What is it doing? And there's a simple story we can tell ourselves. And that simple story is sys.path. Basically, this is a list of strings, directories where Python will look. And this is defined when we start Python. So I start up Python, sys.path is available, and it says it's a list of directories we're going to look in. And the first match wins. And namespace collisions can lead to surprises. So a story. I used to, in my intro classes, I still do this kind of exercise where when I've just taught people the very, very basics of printing and importing and integers, I say, okay, let's write a very, very silly guessing game. And the guessing game is going to choose a random number, and then you have to guess the number. And you only get one guess, too high, too low, or you got it right. Unfortunately, many, many, many people called that program random.py. And if you are in random.py and you say import random, you know what you get? The file, like if it loaded itself, which on the first day of a class is not the best thing to do to people. Well, why did it import itself? Why didn't it go to the standard library? Because if we look at sys.path, we see here that sys.path, it starts with, actually there's a blank there at the top, which shows the current directory. Always, always, always importing starts with the current directory. And then we look in the Python standard library, and there's a zipped version, and there's a directory version, there's a dynamic downloads version, and then finally we look in site packages. Meaning, and site packages is where pip installs things. This means then that if you install something with pip that has the same name as the standard library, it will be completely ignored. By the way, you should not be doing that, right? But that should not exist. But always the current directory has priority, then the standard library, and then site packages. Right, and that's basically what I said here, fine. Now, what if then, this was mine, fine. Okay, nothing too exciting there. Blah, 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 blah. Okay, right, this is just what I said. So we have the current directory, then the standard library, then site packages. What if you want to change it? What if you want to change sys.path? Well, as I said, sys.path is defined when Python starts. Now, you could, in theory, it's a list. You could use list.append or list.insert. Don't do that. Instead, you can set the Python path environment variable. And anything in that environment variable is stuck there right after the current directory, which always gets priority, and right before everything else. So if I say here, for example, Python path equals /hello/goodbye. Now when I load up sys.path, you'll see we've got the empty directory, the current directory. Then I've got these things from Python path. Then I've got the standard library. And then I've got site packages for pip. This is the order in which things are searched for. Okay. So the pseudocode version, can I write a function version of this? Yes. So I'm going to say def my import. And if mod is not in sys.module, so if we've not yet seen this module, what are we going to do? We're going to say for directory in sys.path. We're going to go through it one by one by one. Here's the file name, right? And then if it exists, check to make sure the file exists. Then we're going to load the module. Yeah, we're going to get to that in a moment. And then we break. So if we found it, we break. Otherwise, if not, we'll raise a module not found error. Right, so we're going to go one by one through that directory, try to load our module. It works great, if not, and we get an error. And then we can go through and do all the aliasing. Yeah, we'll talk about load module in just a moment. So there's some problems with this story. Some of the things in sys.path are not directories. And modules are stored in many different places. And here's a funny thing. If you have a file called time.py in the current directory, it still imports the time module, which means that something in my story is wrong. And what about, you might have noticed in the past, PYC files. You import a module and you end up with this PYC file as well. And the last thing is, what about packages? What if I have a directory containing modules? So this is complicated, right? There are a lot of different options here. And so remember I said that import basically does two things. We are finding and we are loading. Well, Python defines two kinds of objects for us, and they are called finders and loaders. And a finder says, does this module exist? And then if it does, where is it and how should I load it? And a finder's job is to return what's called a module spec. It's a special kind of object that contains the loader. So I basically say to the finder, find me this module. It comes back and says, here's the module spec, here's how you're going to load it. A loader, meanwhile, well, it knows how to create a module object. It executes the module file, and it populates that object, meaning we're going to have an empty module, we're going to execute the module file, we're going to use the result to populate. So we have finders and we have loaders, and each one has part of this job, and we can also just have an importer that does both of these. Okay, so how does this work then? What is going on? So we have something known as the meta path. sys.path is where should we look for the files. The meta path is a list of finders and importers, and each of them has a find spec class method. So basically, we're going to say to each of the things in the meta path, find spec for this module. If it cannot find it, it returns none. If it does find it, it returns the module. And then if it can't find it at all, if it does not handle it, it returns none. If it returns the module spec, then it worked. And if it's supposed to handle it but could not, then it raises module not found error. And so each element in sys.metapath gets a chance. So we're going to have a bunch of these finders and loaders. And indeed, we can say here, right, I can do this. In fact, I did this for one finder in sys.metapath. It really exists. Print one finder. And then I'm going to say, find me random. So I'm going to say here, one finder.find spec of random, none. Don't worry about the none. And then print the spec. So what's going to happen? This is basically what happens when I import random. So I'm going to import sys. I'm going to go through it. Fine. What happens? Well, it's going to say, okay, I have a finder object. None, meaning I did not find it with distutils. We're not going to find it there anyway. And then it says, maybe I found it with the frozen built-in importer. Nope. Maybe I found it with just like a frozen importer. Nope. Maybe I'll find it with a pathfinder. The answer is yes. In other words, we see that by going through the metapath, Python tries to find random.py, or the random module, in each of these places. And it finally finds it in the place we originally thought it would be in, a file called random.py. Okay, this is like the normal case that we can expect. Well, what would be some abnormal cases? Well, I mentioned time before. What happens when I want to search for the time module? I say import time. Well, where is that found? Is it in distutils? No. Is it a built-in importer? Yes. This is why if I have a file called time.py, it will never be loaded because the metapath does not give us a chance to get there. We never look at the file system. We're just looking at these built-ins that have special special abilities. Python does this on purpose. Everyone's going to want the time module. Everyone's going to want a handful of other modules. And so by having these automatically available to us right away, we can avoid it. Well, wait, what modules are already loaded this way? Well, we can find out from sys.built-in module names. And these modules are loaded right away. They are not subject to file names. If you can call your files this all you want, they will never be loaded. Well, what about something else? What about something in the standard library? Right? What if I want to load the math module? I say import math. So it's going to look in distutils, not find it. It's going to built in, not find it. It's going to find the frozen importer. Nope. External pathfinder. Yeah, it found it. So even things in the standard library are found there. But notice it found it in this libdinload math stuff. In other words, it did find it as a file, but not as a pure Python file. It found it as a combination Python and C file or compiled file. So that's great. So we have our finder. Our finder finds the module object, and then I said it returns a module spec. And the module spec says, okay, I found the module. Here is how you load it, and here's where you load it from. And the module spec gives us the name, the origin, whether it's cached, what is the loader. It has the loader object on it, and a few other things. So if I want to create a module object, basically I can use, and believe it or not, there is actually such a method, right? We use the module spec object. It has a method called create module. And if this returns a module object, then great. So this is why, by the way, every module has attributes dunder file, dunder loader, dunder spec. These are created by our create module object method. And yes, import lib provides us with something similar. So import lib.util module from spec, and there we go. We have these attributes defined. So I've used the module spec to create an empty module with the bare bones, the basics. But I actually want to load the module. The module object, that's the whole thing we're trying to load. I want to get its classes, I want to get its variables, I want to get its data in there. So how does that happen? Well, our module object exists, but it doesn't have any of the definitions. We'll need to load them. And here's another surprise that many people have. When I load a module, I execute it. That's very surprising to people, right? Usually you think I've loaded a module, I've imported a module, okay, I get its definitions. But in Python, we don't have this separate sort of definition stage. In Python, if the module has a variable, then the assignment needs to run in order for the variable to exist. And the variable has to exist before we can import it. If there's a function, the def needs to run. If there's a class, then class needs to run. And so when we import a module, when we load a module, we run it top to bottom. Every single line there runs. How's that going to happen? The answer is exec. Now, if anyone here is saying, oh yes, I use exec all the time, don't do that. Exec is one of the most powerful and dangerous functions in Python. It takes a string and it says, I'm going to treat you like a little Python program. Go run. But that's great unless sometimes I see people get input from the user and run that with exec. You can only imagine, I've heard rumors that there are some bad people on the internet and they might take advantage of such a thing. So if I say here, here's my string, print hello, name equals Reuven, print goodbye, and then I say exec for that, hello and goodbye are printed, and the name variable is defined. And what if I say this, print hello, name, print? Here's a second version of exec. I can exec into a dict. If I pass exec, not just the string, but also a dictionary, then after I run the exact string, I have inside the D dictionary something named. Why am I telling you this? Because module objects have a dunder dict. Any key in this dictionary is an attribute in the module. So here's what our loader is going to do. It's going to read the source code from the module into a string. It's going to execute it with exec. It's going to pass a second argument, the dunder dict, from our module object. And that's how all the globals in the module become attributes in our, all the globals in the module file become attributes in the module object. And this is one of those things I did not pay attention to for years, right? How can it be that it feels like all the things in my module are global variables, but after I'm done loading, they're all attributes on the module object. And this is how it happens. And sure enough, we can say spec.loader.exec module random, and that's exactly what it does. Basically goes to the module, sucks up all of the variables that were defined there, and then it gives us a module object, and that module object then, of course, has methods and classes and all that other stuff. That's a lot. Just a tiny bit more. So all this is customizable. We can create our own custom finders. We can create our own custom loaders. Now, why in the world would I want to do that? I will tell you, I do not want to do that. But I spoke with someone maybe about 2 years ago who had created a custom loader to store Python modules in, if I remember correctly, in a database. And so in addition to storing the modules in memory, in a file, in a zip file, he stored it in a database. And that way his custom loader was able to, his finder and loader were able to find it there and retrieve it from there. This is a very open system that allows us really to work with many, many different possibilities. So what happens when you import a module? Let's review. So first, Python checks to see if the module has been cached, if it's in sys.modules. If it finds it there, it says, great, I don't have any work to do. And then it just assigns the variable. Which variable? The module variable, the from import alias, the from import names, or even as with an alias. If it's not been cached, then it goes through every single finder in sys.metapath. One by one, each gets an opportunity to find the module. If it finds it, great. If not, it passes it along to the next one. And if none of them finds it, you get an exception. The finder that works, the finder that actually worked to find the module, it returns a module spec object. And that module spec object can be used to create a new empty module object. And that empty module object then is loaded into, thanks to the specs loader, little by little, from the file, which is executed, into the dict, making those globals into attributes. By the way, if this means that if your module, right, if you have a module that has print, when someone imports from it, it will be printed. If someone has a while loop in their module, then when you import it, that while loop will run, right? You can do all sorts of evil, terrible things in your module that when someone imports it, will run. Do not do that. Or if you do it to your colleague when they're getting a cup of coffee, you did not hear it from me. Now, a few words about packages, right? Because we really don't have time to go into them. Packages, we often put them in the same basket as modules, but packages are basically directories of modules, right? They allow us to have multiple modules that are within the same project with the same name. Like, I don't want to have a crazy long file, or maybe I'm collaborating with other people, and so each of us can work on a separate file in the same directory. When we have a package, there's a few more attributes, especially the dunder path attribute that is populated. And then we also need to keep track of what level we're at, because you can have a package, or a package in a package, or a package, and so on and so forth. Right? So you have to keep track of where you are, which is useful then for keeping track of, relative imports, for example. Now, this does add some complexity, but it doesn't change the overall sort of things that I said here. And so at the end of the day, I always tell people that modules are one of the simplest things in Python. And that is true if you are using them, if you are importing them. But the very simple, straightforward, easy to use API that we use as hackers, programmers on Python, hides an incredible amount of depth and complexity that is meant to deal with a whole lot of other things, including where do we want to load it from, and where, what sort of storage was used. I'll just add one more thing, which is packages and modules in Python are, in my opinion, one of the messiest things in the language, right? They lead us because in some languages you can import, or not import, in some languages you can install multiple versions of the same package and just import the one that you want. Not so in Python. In Python, if I if I install NumPy 1, then I cannot have NumPy 2. If I install NumPy 2, I cannot have NumPy 1. This, of course, has led to virtual environments and all sorts of other stuff to basically paper over this issue. It's messy, it's annoying. No one has a fantastic solution, but there are a lot of solutions out there, including, as I mentioned, virtual environments. But a whole lot of that stems from this. And I'll tell you, just in the last month or two, I've started thinking, not talking to anyone who actually knows more about this, because there have been a lot of proposals to how to solve this, and no one has done it. But I keep thinking, what if we could install multiple versions? What if we could deal with that with import? And maybe we can hope. But for now, the API that we use with import is pretty straightforward. And I hope this helped you to understand a little bit more of what's going on behind the curtain there. All right, questions, folks?
We still have a few minutes left, so let's see. Okay, let's see. The first question for Reuven is if the modules are cached, when there are still cases present during error on cyclic.
I don't know. I didn't think that was possible. That should not happen. I mean, maybe someone's like deleting the caching. Maybe, I don't know. I really don't know. In theory, that should not happen. But, in theory, there's no difference between theory and practice. And in practice, there is. So I don't know.
Okay, so maybe we can.
Let's try a question that I can answer.
Next one. Could you provide some recommendations about efficiency and self-loading modules?
So I think one thing that I understood after like researching this talk is how important / useful it is to keep your modules short and small. Much better to have many small modules than to have one huge one. In no small part because then you can really, if you're worried about memory usage or execution speed, right? If you import one small module, that'll take less time to do both than one large one. I mean, that's there was some talk for a while. I think there was even a PEP for this, for lazy loading of modules. The idea being, well, we'll sort of tell Python we want to import this module, and we'll only actually load it when we need it. And it turns out that that was just like super, super complicated to deal with a whole lot of corner cases, and not even corner cases. So keep them short. Don't like do wild things inside the module. And again, like here's something also. Just as modules execute when they are loaded, classes execute when they are defined. You can think of a class as a module without a file. So don't have things execute. Don't have too many things execute inside of your classes, inside of your modules, because that will further delay the execution. At the same time, sometimes you have no choice, right? Sometimes you just have to do it that way.
Thank you. And next is for a question from Kakashif. He asks, why shouldn't we use import? Just because we shouldn't use dunder master directly in general, or is there any other reason?
I think the big reason is like you should not be using these methods directly. It's like I mean, look, something like dunder import is probably not about to change in a major way. But do you really want to bet on that? Like they've guaranteed, the core developers have more or less guaranteed that import will work in a regular, normal way, in a stable way. So you should use it. The moment you start using dunder import, you're using the behind the scenes stuff that in theory could change. I also think just for readability purposes, right? You start doing these seemingly clever things, and a year from now, either one of your colleagues says, what the heck was this? Or here's the worst case. You say, what the heck is this? Like, why did I do this? Right? How many times has this happened to you? You read some code and you say, who was the idiot who wrote this? Oh my God, it was me. Right? And you want to avoid that. So sticking with one of the things we try to do in Python is stick to the standard idioms so that the code will be readable, understandable, and maintainable by others and by ourselves in the future.
Thank you. And next question is, what happens when you import sys module?
Very little. It defines the variable. The sys module is already there. It's part of the Python runtime. It's there from the beginning. So importing sys just defines the global variable. It takes basically 0 time.
Thank you. And next question is there a general solution for fixing module not found error for code you don't control, like system packages extruding Python?
I don't think there's a general solution to that. Like, again, if there's a module not found error, it means that something's looking for a module that does not exist, probably because it was not installed with pip. So it was not put into sys packages. Maybe because your Python path needs to be set to look in a certain directory. There are companies I work with where they say, we are going to install our packages into place X. And everyone has to set Python path to include X. But if it's not that, if it's like something if something that's executing elsewhere, I don't think there's a general solution to that. I'm sorry to say.
Okay, next is, does init.py makes a dictionary package?
The answer is, it depends on how old you are. So it used to be the case that indeed, if a directory did not contain dunder init.py, it was not a package. That has changed. I don't remember exactly in what version, but it's been a while already. Basically, if you have a directory now in sys.path, it is considered to be a package, and dunder init.py is a nice add-on. It's helpful, but it's not crucial. You will still be able to load that directory as a package.
Okay, and next question is from P. P is asked, so circular import is not a problem nowadays?
As far as I know, not. I mean, I'm sure there are corner cases that I don't know about, but the whole idea of the like caching is to stop it. Yeah. I would be. So after I absolutely positively want to see that. Yes. And then I'll see it again and again because it's circular.
Let's answer the last question. Does the import thread safe?
I have to assume not. Just because I think the general assumption in Python should be nothing is thread safe unless it's like explicitly thread safe. But like if you're importing inside of a thread, what? What are you doing? like don't do that. I mean, it's like you can import inside of a function, and there are times you might want to do that, but importing inside of a thread seems weird and not recommended. Exciting if you want to live on the edge, you know?
Okay, we still have a few questions left, but due to the time constraint, we need to end here now. So if you still have any question, please come in front and chat with Reuven. And the next side is we have 1 hour for open space and the post session. So if you want to chat with those post speakers or chat with others, please go to the hall in front of the PSF hall. And finally, let's thank Reuven again. Thank you.